Okay, the next video I'm going to be doing from some stoichiometric calculations is not actually involving a titration itself. This is just simply what we call a dilution calculation. Alright, so this is where we're diluting one volume of solution to make another volume of solution, and we're going to use the fact that anytime you do a dilution concentration calculation, okay, the number of moles doesn't change. Okay, because what you're doing is you're just taking the number of moles that you've got within a flask. Okay, so let's say here we've got this small flask here. Okay, and let's say for example this has 2 moles in it. Okay, all we're going to be doing is putting that into a much bigger flask, which is still got 2 moles in it. Okay, now the concentration is going to change, because if this is a 1 litre flask, this is going to be 2 moles per litre, and if we put this into a 4 litre flask, okay, this is going to be 2 moles per 4 litres, or 0.5 moles per litre. Okay, so what happens is the concentration changes. As you can see there, we've got 2 moles per litre here versus 0.5 moles per litre here, but the actual number of moles here inside doesn't change. All we're doing is changing the volume. Okay, so that's what we're going to be doing for this one. So what we've got here, looking at the question, is we've got 11 moles per litre, alright, of hydrochloric acid, and we're going to be using it to make 2 litres of dilute acid of concentration 2 moles per litre. Okay, so what we do is we use just a pretty simple equation, which I'm going to go through here, and I'm going to show you it is C1V1 equals C2V2. Okay, again, because number of moles doesn't change. Number of moles equals concentration times volume, and because concentration doesn't change, okay, it's not going to affect us now. Sorry, I'm just going to change that to make sure it looks like a multiply there. Alright, so number of moles doesn't change, so we can use this equation. So what we had, alright, was 11 litres in our first one, and we wanted to know what volume we were using there. Okay, in the second one we had a concentration of 2 moles per litre, and we had 2 litres that we were using there. So we took 11 moles, we know what volume of 11 mole solution we need to use to make a 4 mole one, okay, to get it to be equal to 4. So it's just simply volume equal, ooh, that looked dodgy, sorry. Volume equals 4 over 11, just rearranging, we just want to divide by 11 on both sides to get rid of that one. So 4 divided by 11 is 0.36, and now we need our units, which is litres. Okay, now we've answered this to 2 significant figures. Okay, so if we go back to our question up here, see each of these, the moles per litre up here, the volume here, and the moles per litre here, all of that one's actually got 3 significant figures, and that one's got 2, and that one's got 2 there. Okay, so we answered to our least accurate one, which is 2 significant figures, so we give our answer to 2 significant figures here. If we wanted to write this another way, we could say 360 millilitres, and that would still be the 2 significant figures. Okay, so that's a concentration conversion calculation. Alright, we keep in mind that we use this thing of number of moles stays the same, so we use this equation over here, okay, of C1V1 equals C2V2. Okay, and that's an easy, quick way you can do your concentration calculation changes. Alright, you might want to go back and watch this one again, alright, because I know it's kind of the first time we've sort of seen it. So have a look through it, let me know if you need more help. Thanks guys.